Hello students, myself Dr. Girish Kun, Assistant Professor, Mahatma Phule Arts and Commerce College, Panvel. Today we are going to discuss the crystal systems and Bravais lattices. Firstly, we will see the crystal systems. A three-dimensional space lattice is generated by repeating the translation vectors like A, B, C. These are the translation vectors. If we repeat these translation vectors in a three-dimensional space, we will get the crystal structure. Okay, crystals are grouped under 7 systems on the basis of shape or the geometrical shape of the unit cell. So basically the crystals has been classified in a 7 system, or there are 7 types of crystal systems are there on the basis of shape of the unit cell or the geometrical shape of the unit cell. So these 7 systems are distinguished from one another by their lattice parameters, and as previously we discussed, these lattice parameters are the A, B, C, which are nothing but the primitive translation vectors, and alpha, beta, gamma, which is nothing but the interfacial angles between the different types of axes x, y, z. So let us see the different crystal systems are there. So first one is a cubic crystal structure system, then tetragonal, then orthorhombic, then rhombohedral, which is also called as a trigonal, then hexagonal, monoclinic, and lastly triclinic. So these are the 7 crystal structure systems are there. Okay, first one is a cubic, then tetragonal, then third one is a orthorhombic, rhombohedral, hexagonal, monoclinic, and lastly triclinic. So these are the 7 crystal structure systems are there. I will recommend you to remember these 7 crystal structure system in the same order, and the reason is there why I am suggesting you to remember these different 7 crystal system in this order. So simple reason is there because I am going to give you the trick how to remember 7 crystal systems. So what you can do, you can remember this short form, which is a CTORHMC, or you can remember this long form also, which is nothing but the Chief Technology Officer from Rational Hybrid Monte Carlo. Okay, so each initial letter of this sentence correspond to these 7 crystal structure system names. Okay, so like, or the each letter of this short form is also related with the different types of a crystal structure system in the same manner or same way that I suggested you. So firstly, C stand for cubic, then secondly T stand for tetragonal, O stand for orthorhombic, then R stand for rhombohedral, and you people has to remind or remember that rhombohedral, the another name is a trigonal system. Then H stand for hexagonal, M stand for monoclinic, and the C for the last triclinic. The C is coming from the last letter triclinic word. So the last letter of the triclinic word is a C. So this is a C. So in this way you can remember 7 crystal system, and I have provided you the trick how to remember this 7 crystal system. Okay, so if you remember this 7 crystal system, then you can draw their shapes also, and you have to write the relation between the different lattice parameters. So as I told you, the different lattice parameters are nothing but the primitive translation vector A, B, C, and the interfacial angle alpha, beta, gamma. So let us see one by one different crystal systems. So first one is a simple cubic crystal structure system is there, where these are translation vectors a, b, c are equal, and these interfacial angles alpha, beta, gamma are equal and 90 degree. So this is for the cubic crystal structure system. Then the second one is a tetragonal, which having a equal to b not equal to c, alpha, beta, gamma are equal and equal to 90 degree. Then for orthorhombic, these three primitive translation vectors are not equal, whereas these interfacial angles are equal and 90 degree. So from these three crystal system, what you people can notice is that only only change is there is about the primitive translation vector relation, and these interfacial angles are having the same relation. Okay, so in a simple cubic, a equal to b equal to c, whereas in a tetragonal, a equal to b but not equal to c, and in orthorhombic, all these three primitive translation vectors are not equal, and for all these three crystal system, interfacial angles are equal and 90 degree. So these are the hint, and that's why I recommended you to remember these crystal system in that order. Now the next one is a rhombohedral. So in a rhombohedral, all translation vectors are equal, then all interfacial angles are equal, but they are not 90 degree. So this is the main difference. This is the main difference between the cubic and the rhombohedral. After that, hexagonal crystal structure system we have discussed. In the hexagonal cubic crystal structure system, the lattice parameters a is equal to b but not equal to c, and alpha and beta are equal and 90 degree, whereas gamma is a 120 degree. So this is the relation between the lattice parameter for the hexagonal crystal structure system, and the shape or the geometrical shape of the hexagonal crystal structure system has been shown over here. Okay, so now the next one is a monoclinic crystal structure system. In the monoclinic crystal structure system, similar to hexagonal crystal structure system, the lattice parameter having the same relation, a equal to b not equal to c, whereas alpha and gamma are equal. Over here alpha and beta are equal. Over here alpha and gamma are equal and 90 degree, but in a monoclinic crystal structure system, beta is not 90 degree. Beta is not 90 degree, and it is not a defined angle. It is not the specific angle. Whereas in a hexagonal crystal structure system, the beta, gamma, alpha all are the defined one. Like alpha, beta, they are 90 degree. They are fixed. They cannot be changed. Whereas in whereas the third angle gamma is 120 degree. That's not the case over here. And the last, the crystal structure system is the triclinic. In the triclinic crystal structure system, a is equal to b. Sorry, in the last triclinic crystal structure system, the primitive translation vectors, they are not equal. They are different. So a not equal to b not equal to c, whereas the interfacial angles also not equal. So they are different and not 90 degree also. So alpha not equal to beta not equal to gamma not equal to 90 degree. Okay, so what it means, among the alpha, beta, gamma, not single angle is a 90 degree. I mean, alpha is other than 90 degree, beta is other than 90 degree, gamma is also other than the 90 degree. So if one angle will be 90 degree, it will not be triclinic crystal structure system. So in a triclinic crystal structure system, alpha, beta, gamma, these angles are different and they are different from the 90 degree. So this is the about the 7 crystal structure system. So now the Bravais lattice. As previously we have discussed, a lattice is a arrangement of points in a 3 dimension. Okay, Bravais lattice is a little bit different. Okay, of course it is related with the arrangement of points. Okay, arrangement of points or arrangement of atoms in a three-dimensional space. So Bravais was a scientist. Bravais was a scientist who discovered that as previously we discussed, there are only 7 geometrical shapes are possible with the crystal structure system. But in these 7 geometrical shapes, different arrangement of atoms can be there. Okay, different arrangement of atoms can be there. So Bravais discovered or invented that how much different arrangements can be possible. So he was the one who discovered that how many arrangement of atoms or molecules or lattice points with this 7 crystal structure system or with these 7 different geometries we can do. Okay, so Bravais in 1948 discovered that there can be 14 types of a unit cell under 7 crystal structure system. Okay, so possibility of only 14 types of a unit cell will be there, and they are commonly called as a Bravais lattice. They are commonly called as a Bravais lattice. Over here I have shown you the or I have intended to understand you the different crystallographic axes having the different primitive vectors, translation primitive vectors, A along the x direction, B along the y direction, C along the z directions, and these primitive translation vectors are nothing but the intercept made by the unit cell on these 3 crystallographic axes. Okay, after that over here the alpha, beta and gamma, these are the angles, interfacial angles between the 2 axes. Alpha is between the y and z, beta is between z and x, and gamma is between x and y. So these are the different interfacial angles. So now the space lattice formed by the unit cell are marked by the following symbols. Means the space lattices are going to form with the different types of unit cell. So these different types of unit cell we are going to symbolize in order to understand for ourselves. So first one is a primitive lattice, which is represented by P, and this primitive lattice is a arrangement of atoms or points. Basically it is a point. Okay, arrangement of points in a 3-dimensional space. So this P is having the lattice points only at the corners of the unit cell. What it means? The points are located at the corners only. So basically it is related with the primitive cell, right? And others are related with the non-primitive cell. So one by one we will see the symbol for the non-primitive cells also. So next one is a body-centered lattice. Body-centered lattice is related with the inverse type of geometry. So inverse type of symmetry. So it is represented by I, and it having the lattice point at the corner as well as at the center of the body of the unit cell. Center of the body of the unit cell. So body centered lattice is represented by I. I stand for inverse, and that is the type of symmetry. Okay, so that stand for I. After that, face centered lattice is also there, and that face centered lattice is represented by F, which having the atoms at the corner as well as at the face center of the unit cell, as well as at the face centers of the each centers of the face. Okay, so at the for the face centered lattice, F is the symbol, and this face centered lattice having the corners atoms or points at the corner as well as at the center of each face of the unit cell. Then the base centered lattice is represented by capital C letter, and this base centered lattice having the points at the corner as well as at the top and bottom of of the base centers of the unit cell. It means the extra points will be there at the top center and the bottom center of the unit cell. Okay, so this is about the different types of symbol that has been used by the Bravais in order to differentiate the different types of lattices. So now over here 14 Bravais lattices has been shown with the relation between the lattice parameters and their shapes has been specified over here. So for cubic crystal structure system there are three types of unit cells are there. One is a cubic primitive, so it is having the atoms only at the corners, whereas a body centered and face centered. For body centered it is represented by I, for cubic face centered it is represented by F. So these are the Bravais lattices P, I and F. Three Bravais lattices will be there for the cubic crystal structure system. For tetragonal, two type of Bravais lattices are there. One is a simple or primitive one, and another one is a body centered. So tetragonal I. So I stand for inverse or body centered type of lattice. And for orthorhombic, this is the special crystal structure system who having the all type of primitive as well as a non-primitive lattices. Okay, so you can see for orthorhombic primitive unit cell is there, then base centered non-primitive cell is there, then body centered and face centered. So all type of lattices are there for the orthorhombic crystal structure system. Then the monoclinic having the primitive and the base centered, and for the triclinic only, so at this side only single lattice system has been specified, whereas at this side or at the left side the lattices with a certain crystal structure system they are more than one. Okay, so over here single lattices type of crystal structure system has been specified. So triclinic, rhombohedral and hexagonal are the crystal structures who having the only primitive type of a lattice system or the Bravais lattice. Okay, and cubic, tetragonal, orthorhombic and monoclinic, these are the crystal structure system who having the primitive as well as non-primitive cells, or they having the arrangement of a primitive and a non-primitive lattices. So if we count together for all this type of a 7 crystal structure system, 14 types of lattices are there. So like for cubic crystal structure 3 type of lattices are there, for tetragonal 2, for orthorhombic 4, for monoclinic 2. So in all it is 11, and these are the 3. So 11 plus 3 is nothing but the 14. So that's why it is called as a 14 Bravais lattices. Over here with the cubic crystal structure system, whatever the relation between the translation vectors and the interfacial angles we have discussed this, the same relations you people have to write. So this is about the Bravais lattices. So basically the Bravais lattice is related with the arrangement of points in a three-dimensional space or with a different crystal structure system. So Bravais was the scientist who discovered that there are different 14 types of arrangement of points is there with the 7 these geometries or these 7 crystal structure system. So that's why it is called as a 14 Bravais lattices. Thank you for watching this video.